What if the hurricanes striking today are not just stronger, but fundamentally different from anything humanity has faced before? What if the winds and rains now pounding coastlines are warnings of a new climate reality, not just random acts of nature? And what if the choice between climate change and natural cycle is not just a scientific debate, but a matter of life, death, and survival for millions? This is the urgent question that dominates conversations every hurricane season. Are storms intensifying because of human-driven climate change, or are we simply living through a natural cycle of ocean and atmosphere patterns? The answer is complicated, controversial, and deeply consequential. For scientists, insurers, policymakers, and families along the coasts, understanding the forces behind stronger hurricanes is not just academic. It determines how we prepare, how we build, and how we survive. To grasp the debate, we need to start with the evidence. Over the past several decades, researchers have observed a trend. Hurricanes in the Atlantic and other basins are becoming more intense. While the total number of storms each year fluctuates, the proportion of Category 4 and Category 5 storms, the most dangerous, has increased. Rainfall associated with storms is heavier, often leading to catastrophic inland flooding. Storm surges, amplified by rising sea levels, are reaching farther inland, swamping areas that once felt safe. The damage costs from hurricanes, adjusted for inflation and population growth, are climbing into the hundreds of billions. These trends are not imagined. They are real, documented, and devastating. The climate change argument focuses on the fuel hurricanes need: warm ocean water. Hurricanes draw their energy from the heat of the sea surface. As human activity, burning fossil fuels, clearing forests, industrializing economies, pumps greenhouse gases into the atmosphere. The oceans absorb much of that excess heat. Sea surface temperatures in the tropical Atlantic, Gulf of Mexico, and Caribbean have risen significantly since the mid-20th century. This means more energy is available to storms, allowing them to intensify rapidly and sustain higher wind speeds. Scientists call this rapid intensification, when a storm jumps multiple categories in less than 24 hours. It is happening more often, and it is one of the clearest fingerprints of climate change on hurricanes. But climate change doesn't just supercharge wind speeds. It also increases the atmosphere's ability to hold moisture. For every degree Celsius of warming, the air can hold about 7% more water vapor. When hurricanes form, they tap into that moisture, producing heavier rainfall. Hurricane Harvey in 2017 is a prime example. It stalled over Texas, dropping more than 60 inches of rain in some areas, flooding entire regions for weeks. Scientists later concluded that climate change made Harvey's rainfall significantly worse. Similar conclusions have been drawn about other storms, from Katrina in 2005 to Ida in 2021. Still, skeptics argue that hurricanes are part of natural cycles. The Atlantic Multi-Decadal Oscillation, AMO, for example, is a pattern of sea surface temperature variations that shifts every few decades. When the AMO is in a warm phase, hurricane activity in the Atlantic tends to increase. Proponents of the natural cycle argument point to historical records showing periods of high activity, like the mid-20th century, followed by quieter decades. They argue that what we are seeing now could simply be another peak in a long-standing cycle, not necessarily a product of human influence. The challenge with this argument is data. Reliable hurricane records only go back about 150 years, and satellite monitoring, which gives us a full picture of storms across the Atlantic, only began in the 1960s. Before that, many storms likely went undetected if they didn't hit land. This means our baseline for what is normal may be incomplete. Natural cycles do exist, but separating their influence from the clear warming signal of human-driven climate change is difficult. Scientists debate how much of today's storm intensity is caused by cycles versus long-term warming. The consensus, however, is growing. Climate change is not the only factor, but it is a major one, and it is pushing storms into territory more dangerous than natural cycles alone would allow. The consequences of this debate are immense. If stronger hurricanes are simply natural cycles, then the future may hold periods of calm, and adaptation might be manageable. But if climate change is the primary driver, then the risks will only escalate as greenhouse gas emissions rise and oceans warm further. This means not just more intense storms, but longer seasons, greater rainfall, and storm surges capable of inundating entire coastal cities. The stakes are nothing less than the habitability of some regions. Communities on the front lines don't need academic certainty, they need answers that guide action. For residents of Florida, Louisiana, Texas, or the Carolinas, the reality is that storms feel stronger, floods rise higher, and recovery costs more. Insurance markets are collapsing, evacuation orders come more often, and memories of past storms haunt every new forecast. For them, whether it's climate change or natural cycles, matters less than the undeniable fact: hurricanes are getting harder to survive. Globally, the same patterns are playing out. In the Western Pacific, typhoons are striking the Philippines, China, and Japan with increasing intensity. Cyclone Idai in Mozambique in 2019 devastated communities with flooding. Cyclone Mocha in 2023 struck Myanmar with catastrophic force. Around the world, scientists are seeing storms that break records not just for wind speed, but for rainfall and storm surge. The fingerprint of a warming world is visible across every ocean basin. Economically, the costs are staggering. In the US alone, hurricanes account for the majority of billion-dollar disasters. Recovery often stretches for years, with infrastructure, housing, and livelihoods disrupted. Insurance companies face losses so great they withdraw from entire regions, leaving families unprotected. Governments pour billions into rebuilding, often in the same vulnerable places, only for the next storm to destroy them again. The question of whether storms are natural cycles or climate change is not just scientific. It shapes budgets, insurance markets, and long-term planning. The human dimension is equally urgent. Hurricanes disproportionately impact vulnerable populations: the poor, the elderly, and marginalized communities. These groups often live in more fragile housing, have fewer resources to evacuate, and face greater challenges in recovery. Stronger storms widen these inequalities, hitting those least able to withstand them. If climate change is amplifying hurricanes, then it is also amplifying injustice, turning storms into crises of equity as much as weather. Some argue that focusing on the cause, climate change versus natural cycles, misses the bigger picture. Regardless of the driver, hurricanes are becoming more destructive, and society must adapt. This means investing in stronger infrastructure, elevating homes, building seawalls, restoring wetlands, and redesigning drainage systems. It means rethinking where we build, retreating from the most vulnerable coastlines. It means reforming insurance and aid systems so families are not left destitute after every storm. The science is critical, but the urgency is clear. Storms are changing, and we must change with them. Yet denial remains powerful. Some political leaders downplay the role of climate change, framing stronger hurricanes as natural variations to avoid making difficult policy choices. Others use the uncertainty in data as an excuse for inaction. This paralysis is dangerous. Every year of delay means more warming, more risk, and more communities exposed. The debate between climate change and natural cycles may never be fully resolved to everyone's satisfaction, but waiting for certainty before acting could be catastrophic. The scientific consensus is not absolute, but it is strong. Climate change is making hurricanes more intense, wetter, and more destructive. Natural cycles exist, but they cannot fully explain the trends of the past several decades. Human activity is rewriting the rules of storms, and the planet's oceans and atmosphere are responding with unprecedented force. The choice we face is whether to continue fueling this change or to confront it before it overwhelms us. At the end of the day, the question, climate change or natural cycle, may be less important than another. What are we going to do about it? The storms are real, the damages are undeniable, and the risks are growing. The science offers warnings, but the responsibility lies with us to prepare, to adapt, and to reduce the emissions driving the climate into uncharted territory. For now, every hurricane season serves as a reminder. Each storm that intensifies rapidly, each flood that drowns a city, each surge that overwhelms defenses is a signal. Whether you call it climate change or a natural cycle, the reality is the same. Stronger hurricanes are here, and they are testing the limits of our resilience. The time to argue over labels is running out. The time to act is already upon us. When we talk about stronger hurricanes, the debate often comes down to two competing narratives. Are these storms growing more destructive because of human-caused climate change, or are they simply part of Earth's natural rhythms? To answer that, we have to step into the worlds of science, history, and lived human experience. And what we discover is that the truth is not neat. It lies in overlapping forces, both natural and human-driven, shaping the hurricanes that now pound coasts with terrifying force. To begin, consider what hurricanes need to form and strengthen. They thrive on warm ocean waters, moist air, and favorable wind patterns. These ingredients have always been part of Earth's climate system, and throughout history, storms have ebbed and flowed in cycles. Long before humans were burning coal and oil, hurricanes were reshaping coastlines, toppling forests and sinking ships. That is undeniable. But what is also undeniable is that in the last century, humans have altered the planet's atmosphere and oceans at a pace never before seen. By burning fossil fuels and releasing carbon dioxide, we've supercharged the very ingredients hurricanes rely on. The evidence lies in the oceans themselves. Sea surface temperatures across the Atlantic and Gulf of Mexico have climbed steadily over the past several decades. Even small increases make a big difference. A hurricane's winds are fueled by the heat energy stored in the water. The warmer the sea, the more fuel available for storms to intensify. Scientists have tracked an increase in rapid intensification events, where a storm jumps from a tropical storm to a major hurricane in less than 24 hours. That used to be rare. Now it happens multiple times a season. Communities that might have had days to prepare for a Category 1 storm suddenly face a Category 4 barreling toward them with little warning. At the same time, warmer air holds more moisture. The atmosphere today can carry more water vapor than in the past, and hurricanes are tapping into that. The result is storms that dump staggering amounts of rain. Hurricane Harvey in 2017 was a turning point for many scientists and the public alike. It stalled over Texas, releasing more than 60 inches of rain in some areas. Studies later showed that climate change had made that rainfall significantly heavier than it would have been in a pre-industrial climate. Harvey wasn't just a storm, it was a wake-up call. But skeptics point to history. They argue that the 1950s and 1960s also saw bursts of intense hurricane activity. They point to the Atlantic multi-decadal oscillation, a natural climate pattern that shifts ocean temperatures every few decades. When the AMO is in its warm phase, hurricanes become more frequent and more intense. By this argument, today's storms could simply be another crest in this natural cycle, one that will eventually decline. After all, nature has always had its ups and downs, long before humans were measuring or modeling climate change. The difficulty lies in data. Reliable records of hurricanes only go back about 150 years, and for much of that time, storms were tracked only if they struck land. Many hurricanes that stayed at sea went unnoticed. Satellites, which give us a full picture of storm activity, only became available in the 1960s. This makes it hard to compare today's storms with those of centuries past. What we know is based on a limited window of observation. That gives skeptics room to argue that what looks like unprecedented activity could simply be part of a longer natural cycle we haven't fully documented. Still, the fingerprints of climate change are increasingly clear. Consider storm surge, the wall of water pushed ashore by hurricane winds. Rising sea levels, driven by melting ice and thermal expansion of oceans, make surges higher and more destructive. Even if storms were no stronger than before, higher seas mean flooding reaches farther inland. A Category 2 storm today might cause the same surge damage as a Category 3 decades ago, simply because the baseline water level is higher. Add to that the trend of stronger storms and the threat multiplies. Cities like Miami, New Orleans, and Houston now face flooding risks that would have seemed impossible half a century ago. Economics underscore the stakes. Each major hurricane now costs tens of billions of dollars in damages. Part of that is because there are more people and more property in harm's way. Florida's coastline, for example, is lined with millions of homes that did not exist in the mid-20th century. More assets mean higher losses when storms hit. But even when adjusting for population and wealth growth, the damage trends still show hurricanes hitting harder. That suggests the storms themselves are more powerful, not just that there are more targets in their path. The insurance industry has become an unexpected voice in this debate. Insurers do not argue over cycles versus climate change. They focus on risk. And the risk they see in Florida, Louisiana, and other coastal states has become too high. Companies are pulling out, raising premiums, or refusing coverage. Reinsurers, the global companies that insure insurers, are sounding alarms. They calculate probabilities based on past losses and future projections. And their models show what scientists have been warning. Storms are getting more expensive, more dangerous, and more likely. Whether you call it climate change or not, the market is responding as though it is real. Communities, meanwhile, live with the consequences. For coastal residents, the science debates feel distant compared to the lived experience of stronger storms. Families in Puerto Rico who endured Maria in 2017 don't care if it was a cycle or climate change. They care that the storm left them without power for months. Residents of New Orleans who survived Katrina in 2005 or Ida in 2021 know that storms are testing their city's defenses like never before. In small towns from North Carolina to Texas, each hurricane season brings the same dread. Will this be the year everything is lost? Globally, the story is the same. In the Philippines, typhoons are breaking records for wind speed and rainfall. In Mozambique, cyclones are striking with unusual frequency and devastating force. In Japan and China, storms cause billions in damages each year. The Pacific and Indian Oceans show similar trends to the Atlantic. Fewer storms overall, perhaps, but more of them at the highest intensities. And the science points to climate change as the driver, amplifying storms in every basin. Of course, acknowledging climate change as a major driver does not erase the role of natural cycles. Both forces operate together. The AMO, El Niño and La Niña and other natural oscillations still influence hurricane frequency and trends. But climate change tilts the scales. It loads the dice so that when natural cycles favor activity, the storms that result are stronger and wetter than they would have been otherwise. This is why many scientists frame the issue not as climate change versus natural cycles, but climate change on top of natural cycles. It's an additive effect, making storms more dangerous during active periods and sustaining risks even during quieter ones. Policy decisions hinge on this understanding. If storms were purely natural cycles, governments might focus on short-term adaptation, building stronger levees, elevating homes, and waiting for the cycle to shift. But if climate change is a major driver, then adaptation alone is not enough. Reducing greenhouse gas emissions becomes essential, because without mitigation, the risks will keep escalating for centuries. That is why this debate is more than academic. It shapes whether nations invest in clean energy, retreat from coastlines, or continue rebuilding in harm's way. The psychological dimension cannot be ignored either. Human beings crave certainty. To hear that storms are simply part of nature's cycle offers a kind of comfort. It suggests that today's suffering will pass, that calmer decades will return. To hear that storms are fueled by climate change is harder, because it means the trend will not reverse without profound global action. One explanation feels temporary, the other feels permanent. But comfort does not equal truth, and as storms break record after record, denial becomes harder to maintain. So where does this leave us? The data says storms are stronger. The science says warmer seas and atmospheres are amplifying them. Natural cycles still exist, but they cannot explain the full scale of what we are witnessing. The reality is that we live in a world where both forces interact, but human-driven climate change is pushing hurricanes into new, more dangerous territory. That means preparation must evolve, policies must shift, and societies must face hard choices about where and how to live. The story of stronger hurricanes is not just about physics. It's about people, places, and futures. It is about whether Miami, New Orleans, and Houston can remain viable cities. It is about whether island nations can survive rising seas and endless storms. It is about whether farmers, workers, and families inland can weather floods that reach farther every year. The debate over climate change versus natural cycles may never fully end. But for the people standing in the path of the next hurricane, the answer already feels clear. The storms are stronger, the costs are higher, and the world has entered an era where resilience is no longer optional. It is essential. Every time a hurricane forms in the Atlantic, a familiar debate resurfaces. Are these storms stronger because of human-driven climate change, or are they simply part of Earth's natural cycles? For scientists, politicians, and citizens alike, the question is more than academic. It is a matter of survival. The answer determines not only how we explain today's destruction, but also how we prepare for the storms of tomorrow. And as each new hurricane season delivers storms that defy expectations, the urgency of this question grows heavier. Let's begin with what we know for certain. Hurricanes are getting stronger. Data from recent decades shows a clear increase in the proportion of high-intensity storms, categories 3, 4, and 5. Rainfall associated with these systems is heavier, flooding reaches farther inland, and storm surges are amplified by rising sea levels. The evidence is undeniable, but the why remains contested. Is it climate change, natural cycles, or a complex blend of both? The climate change explanation begins with physics. Hurricanes draw energy from warm ocean waters. The hotter the sea surface, the more fuel storms have to grow. Human activity, burning fossil fuels, clearing forests, industrializing economies, has driven a sharp rise in greenhouse gases, trapping heat in the atmosphere and oceans. The oceans now contain more stored heat than at any point in recorded history. That heat is available for storms to use. This explains the phenomenon of rapid intensification, where a storm jumps from weak to catastrophic in just a day. Hurricane Michael in 2018, Hurricane Laura in 2020, and Hurricane Ian in 2022 all underwent such explosive growth. These are not isolated events, they represent a new pattern. Climate change also boosts rainfall. A warmer atmosphere holds more moisture, roughly 7% more for every degree Celsius of warming. Hurricanes, which act as giant heat engines, pull this moisture into towering thunderclouds and release it as torrential rain. That is why storms like Harvey in 2017 or Florence in 2018 produced catastrophic flooding, even far inland. Climate models suggest this trend will intensify, making rain-driven floods one of the deadliest aspects of future hurricanes. Yet natural cycle advocates point to the Atlantic multi-decadal oscillation and El Niño-La Niña patterns. These cycles influence ocean temperatures and wind shear, both critical to hurricane formation. In the 1940s through 1960s, the Atlantic experienced a surge in hurricane activity. Then, for a few decades, activity dipped. Since the 1990s, activity has risen again. Skeptics argue this is not new, it's history repeating itself. To them, today's stormy decades could be followed by quieter ones in the future. The problem is that natural cycles alone do not account for the intensity we are seeing now. A natural cycle may explain why some decades are busier, but it does not explain why storms are reaching higher categories more frequently, or why rainfall volumes are smashing records. Climate change acts like a background force, raising the baseline upon which natural cycles operate. It's as though the dice of nature are still being rolled, but now they are loaded toward higher outcomes. Consider sea level rise. Even if storm strength remained constant, higher seas mean worse flooding. A storm surge today rides on oceans that are already inches higher than they were a century ago. Add the trend of stronger winds and heavier rain, and storm surge damage multiplies. Cities like Miami, Norfolk, and New Orleans face flooding from not only hurricanes, but also high tides and seasonal storms. The line between everyday nuisance flooding and catastrophic inundation is blurring, and climate change is the driver. From an economic perspective, the implications are staggering. Each major hurricane now causes tens of billions of dollars in damages. Insurance markets in Florida and Louisiana are collapsing. Reinsurers, global firms that cover local insurers, are charging more or pulling out altogether. Homeowners face premiums so high they rival mortgage payments, or worse, find themselves without coverage at all. This isn't a theoretical debate, it's a financial crisis unfolding in real time. The root cause? Stronger storms producing higher losses, regardless of whether they're fueled by cycles or climate change. For communities, the distinction is equally urgent but often academic. Whether Katrina in 2005, Maria in 2017, or Ian in 2022, the lived experience is the same. Stronger, deadlier hurricanes leaving behind devastation that takes years to repair. For families who lose their homes, the question of climate change or natural cycle matters less than the reality that storms keep coming, stronger and more frequent. But for policymakers and scientists, the distinction matters because it shapes strategy. If storms are driven mainly by natural cycles, then adaptation, stronger building codes, seawalls, flood defenses might be enough. If climate change is the driver, then adaptation alone will fail unless paired with aggressive efforts to reduce emissions globally. Globally, the evidence of climate change's role grows clearer. Typhoons in the Pacific are reaching higher intensities. Cyclones in the Indian Ocean, like Idai in 2019, are striking areas once considered lower risk. Storm tracks are shifting, bringing hurricanes farther north or south than in previous decades. These shifts cannot be explained by cycles alone. They align with climate model predictions of a warming world. The fingerprint of human influence is showing across every ocean basin. There's also the human toll. Hurricanes hit hardest on the most vulnerable populations. Low-income families often live in weaker housing, have fewer resources to evacuate, and face greater obstacles in recovery. After Maria, Puerto Rico's poorest communities waited months, even years, for power and services to return. After Katrina, low-income neighborhoods bore the brunt of the flooding. Stronger storms, regardless of their cause, widen inequalities. Climate change worsens this, acting as a threat multiplier that disproportionately affects those least able to cope. One of the most chilling aspects of today's storms is how quickly they intensify. In the past, a storm might take days to strengthen, giving communities time to prepare. Now storms jump categories overnight. Forecasting has improved, but the physical reality of rapid intensification means shorter warning times and greater risk of disaster. Climate scientists point to this as one of the most alarming signals of warming seas. For some, clinging to the idea of natural cycles provides comfort. It suggests today's destructive storms are temporary, part of a rhythm that will eventually calm. But the mounting evidence undermines that hope. Climate change is not temporary, it is cumulative. Every ton of carbon released traps more heat, raising ocean temperatures further and setting the stage for stronger storms. Waiting for cycles to shift ignores the accelerating baseline that climate change imposes. So what do we do? First, we must adapt. Coastal communities must rethink building codes, elevate homes, strengthen flood defenses, and prepare emergency systems. Managed retreat, moving people away from the most at-risk areas, will become unavoidable in some places. Insurance and disaster aid systems must evolve to handle repeated escalating losses. Second, we must mitigate. Cutting greenhouse gas emissions is not optional if we want to slow the trend of stronger storms. Clean energy, reforestation, and international cooperation are critical. Without mitigation, adaptation will eventually fail. The storms will simply outpace whatever walls, levees, or codes we build. Third, we must confront the social dimension. Stronger hurricanes are not just about wind and rain. They're about justice, equity, and survival. Policies must ensure that vulnerable populations are protected, not left behind. Recovery must be fair, inclusive, and resilient, not just a rebuilding of the same vulnerabilities that existed before. The debate between climate change and natural cycles may never fully vanish. Natural variability will always play a role in hurricane activity. But the science is clear. Climate change is amplifying storms, making them more dangerous than cycles alone would explain. Ignoring that reality leaves us unprepared. Accepting it forces us to confront hard truths, but also gives us a chance to act. For the people who live along coastlines, this debate is not abstract. It is the difference between survival and catastrophe. Stronger hurricanes are already here. The question is whether we will adapt and mitigate in time, or whether we will let the storms of the future write a story of denial, delay, and devastation. At Crisis Lens, we bring you the stories behind these storms, the science, the human impact, and the choices society faces. Because these questions matter to all of us, not just those on the coast. If you want to understand not just what is happening, but why, and what it means for the future, stay with us. Subscribe to Crisis Lens for more deep dives into the world's unfolding crises. Like this video, share it with others, and join the conversation about what resilience really looks like in the face of stronger hurricanes. The storms are not waiting, and neither should we.